So for both analytical and Euclidean geometry, it is very important that we are able to prove that a quad is a insert other type of quad here. So the quad is the most that you can assume. If you look at a picture and it has four sides, it's a quad. Okay, that's enough. You don't need to prove a quad or whatever. You're not on that level. But if they give you a quad, you need to be able to prove all your main functions, right? So you need to be able to prove a parallelogram, a rhombus, a rectangle, a square, as well as a kite, maybe a trapezium or more like an isosceles trapezium. But yeah, you need to know all of these main quads and like what are their special qualities, what makes them what they are. So we're going to look at this in two ways. You can either look at the properties of their diagonals, or you can look at like what I like to call their outside properties. So that what comes from the definition of the shape. So that is now like the sides and the angles and that type of thing. In this video, we're going to look at like the outside properties and the definition, like our basic things that we know about each of these quads. Then in the next video, we'll look at diagonals. So those are the properties we learned in grade 9. And then there will also be a video where we take what we have done now with each of these properties, and then we will be adding how we would use that in analytical. So for this first video, it's in general for either geometry, and then how we would use that for analytical geometry specifically will be in another video. So we're first going to look at these four. Okay, and there's a reason why I put them all four here together with the arrows, and it's because of the relationships they have to one another. So we're going to start with a parallelogram. The obvious thing, the thing that we straight see from our shape's name, is the parallel. So we know that the opposite sides of a parallelogram are parallel, right? So if they give you a quad and they ask you to prove a parallelogram, you can use that two pairs of opposite sides are parallel. Okay, so that you would have to do maybe with your fun, one of those three, or with midpoint, because that's how you can prove parallel, or you need to be able to take it from what was already given to you, that sides are parallel. So if you can prove that two pairs of opposite sides are parallel, then you can say it's a parallelogram because the opposite sides of a quad are parallel. Okay, so this would be your reason. And you have to say quad because you can't call it a parallelogram while proving a parallelogram. You call it what you know it to be in your reason. Okay, so you say it is a parallelogram because it was an opposite, because the opposite sides of the quad that you were given is parallel. Similarly, we also know that the opposite sides are equal. So if you use that, if you can prove that the opposite sides are equal, your reason for it being a parallelogram would be opposite sides of quad, but instead of parallel, you would say equal. Okay, then there's also one that combines the two, and that would be if you can prove that one pair of opposite sides are equal and parallel. And then the last way here that you can also prove a parallelogram when we're looking at like the outside properties, the main properties, is if you can prove the opposite angles are equal, so both pairs, then you also have a parallelogram. And that reason would be opposite angles of quad are equal. So now we've covered parallelogram, looking at the outside properties. Then, this is very important. With all of your other shapes, it's about what makes them unique. So there is one with the rhombus and with the rectangle that you can straight prove rhombus and rectangle, but for the majority, you are going to have to prove a parallelogram first, and then from there, because it's a palm and it has a special property, then it makes it a whatever else. So this is very important to just keep in mind. So for rhombus, without proving a parallelogram, if you can prove that all sides of quad are equal, so if you can prove all of the sides equal, then that's enough. And that's from just given a quad. If they either gave you a parallelogram or, you don't have the information for all of the sides, if you can prove a parallelogram and then from there you have two pairs adjacent, then that's also enough. So that reason would be it's a palm with adjacent sides equal. Okay, so those are your two ways if we're just working on the outside. Rectangle. Okay, again, similarly, there's one that you can do without proving a parallelogram first, and that would be if you can prove that all four angles are 90 degrees. So all four. Then your reason would be all four angles of a quad is 90 degrees. That's without proving parallelogram first or knowing that it's a parallelogram first. If you go the other route, you have first it's a palm, you proved first a palm, proving one angle to be 90 is enough, okay? Because if it's a palm, but this one is 90, then it makes that 190, which makes that 190, which makes that 190, okay? Because of the parallel lines and the opposite angles being equal. So then one angle being 90 automatically makes it a rectangle. And your reason for that would be it's a palm with a 90-degree angle. So if you have just one, but you already know it's a palm, that's enough. Now a square, this is the one that you hope you don't get. Okay, if they tell you that it's just a quad. If they tell you a bit more, I mean, then it's okay. But if they don't tell you it's a quad, if they don't tell you it's something else, if they just say it's a quad, that means you must do the whole story. You need to start and prove it's a parallelogram. Then you prove it's a rhombus with a special property of a rectangle, or a rectangle for a special property of or both. Okay, now that sounds like a lot. Let's go through it. So one of the things you can do is you can prove it's a rhombus and it's a rectangle. And then your reason would be rhombus and rectangle. That just like think now, if they gave you a quad, how much work this is. It's proving a palm, it's proving a rhombus, it's proving a rectangle, and then you can only conclude. Okay, you can do it though. I'm sure you will survive it. An alternative is you can prove first that's a rhombus, and then if you look, okay, at a rhombus, the thing that's different from a rhombus and a rectangle, but that a square has, because we should know by now, a square is a rhombus and it's a rectangle. It has nothing that the two of those don't have. Any property a square has, either a rhombus or a rectangle has, or both, okay? So you can prove it's a rhombus. Here the thing is all about the angles. So rhombus with a 90-degree angle. Or if you want to, you can first prove it's a rectangle. Now here, by rectangle, it was all about the 90s. By the rhombus, it was all about the sides. So you can prove it's a rectangle with adjacent sides equal. Okay, you don't have to say all sides equal because of the fact that we already know, right? From it being a rectangle, it's also parallelogram. So we already know the opposite sides are equal. So just adjacent is enough. Okay, so that's the route you would go if you wanted to prove all the way from the start to the end from a quad to a square. But you can also start by a rhombus and go to a square, or rectangle, go to a square, whatever. Just depending on what the question is asking, of course. So in the next video, we'll look at how we do this if we use the diagonals. And then in the other videos, we'll go through, okay, now how do we use this in analytical geometry? And how is this useful in analytical geometry?